students, it's Miss Sullivan here, and today we are working on Lesson 18, Writing and Evaluating Expressions with Addition and Subtraction. So this is going to be a continuation of what we've been working on the past several lessons. We've been focusing on writing expressions, and remember, an expression is like a numerical expression where there's no equal sign. Well, today we're going to kind of take that to the next level because we're evaluating expressions. And remember, evaluating means to solve. And there's a couple of different ways we'll learn how to do this over time. But for today, we're basically going to be focused on identifying what the value of the variable is. So we're going to solve for the variable. We're going to try to identify by substituting what the variable equals. And then once we solve for the variable, that's going to lead us to then being able to solve the expression. And this is kind of the steps that we're going to take throughout when we work with expressions or with equations, that we're going to have to solve in some particular steps to get the ultimate answer. So let's start here. How can we show a number? So there's a number increased by 2. So remember, we always underline the key phrase. We have the number 2, and we have what we call a number, and that would be a variable. We can choose any variable. I'm going to choose A. But if we want to show a number A increased by 2, increased is addition by 2, we can write it this way. Or the other way, commutative property is 2 plus A. So can we prove this using a model? Yes, we can. We can use what we call a tape diagram, where we can show that we have a number, which we'll call A, and we're going to increase it by 2. So this would show A plus 2. And if we want to show 2 plus A, well, what do we do with that tape diagram? Well, we reverse it, right? We start with 2, we increase it by A, and this would show 2 plus A. So we've had a lot of practice with this. We should be feeling pretty confident when it comes to that. But today we're going to kind of go next level. We're going to focus on writing that expression with lots of detail. So let's look at example 1. The importance of being specific in naming variables. So concise with what we're saying. When naming variables and expressions, it is important to be clear with what they represent. So that's very important when we're solving. The units of measure must be included if something is measured. So we have to include that. So let's look at this example. We're going to read the variable in the table. We're going to read the description that's incomplete. Notice it says incomplete. And we're going to improve the description given, making it more specific. So reading horizontally, Joshua's speed J. The variable is Joshua's speed J. We're going to let J represent Joshua's speed. Well, how do we be more specific? Well, we're more specific by including the units of measure. So how do we measure speed? There's lots of different choices, but often we say miles per hour, right? You could also say like meters per second, feet per second, things like that. So we could use any of those, but let's use miles per hour. So we're going to improve upon this. We're going to keep this part the same, and then we're going to make additions to it. So the entire thing would say, let J represent Joshua's speed. And this is how we're going to make it more complete, because we're going to add units here. In miles per hour. So we're just building upon what was here. We're taking it and adding units. So we're like eliminating this period here, and we're going to continue on. So let's keep going with that. Rufus's height. Let R represent Rufus's height. Well, how do we measure height? What are just things that we can measure? We can measure inches, centimeters, meters, right? Let's go with inches, because that's what we typically measure in over here in America. So let R represent Rufus's height, and we're going to add to that in inches. So this is an addition rather than rewriting this part again. We're just adding that second part there, okay? Milk sold M. Let M represent the amount of milk sold. Well, how do we measure milk? Yeah, in gallons. So let M represent the amount of milk sold, eliminate this period, and add in gallons. Colleen's time in the 400-meter hurdles. Okay, 400-meter hurdles, that's usually pretty fast. Let C represent Colleen's time. What would we probably measure in? We would probably measure in seconds. Yeah, races are usually typically in seconds. Sean's age. Let S represent Sean's age. Well, how do we measure age? We can measure days, right? We could measure seconds or hours, but typically we say Sean's age in years. Okay? All right, let's go on to the second exercise. So remember, when we are naming variables and expressions, it's important to be very, very clear with what they represent. And when a variable represents a quantity of items, that too has to be specified. So we were doing specific units of measure in exercise 1, but now it's going to be quantity of items. So let's look at this situation. We're going to read the table and we're going to improve the description just like we did before, making it more specific. Caroline CD, we don't really measure that in a unit of measure, but that's a quantity item. So let K represent Caroline CD. How did they improve upon that? They kept this part. Let K represent the number of CDs Carolyn has. Okay, so they added the number of CDs that Carolyn has. So they had to keep a little bit, but add in the number. And we're used to that, right? So let's see what we can do here. Joshua's merit badges. Let J represent Joshua's merit badges. How can we improve upon that? Well, we can say let J represent, I'm going to keep this part, okay? And I'm going to add let J represent the number of, and this is Joshua's merit badges come back in, number of Joshua's merit badges, or the number of merit, you know what, I'm going to change that. The number of merit badges Joshua has earned. Because that's what you do with merit badges. You earn them. So the number of merit badges Joshua has earned. They don't give me much room to write there, so I got to kind of squeeze it in. Rufus's trading cards. Let R represent Rufus's trading cards. This is kind of like our CDs, right? Like, what do you have with trading cards? You buy them, you collect them, right? So let's let R represent. So I'm coming from this part. I don't have enough room. I'm not gonna be able to repeat this part right here. Okay, so those dots mean that I'm repeating the underlined portion here. So let R represent the number. So again, you can see we're using that phrase, the number of trading cards. I don't have room, so I'm just going to say cards. The number of cards in Rufus's collection. Because you collect trading cards. Let's do the last one, milk money, okay? Let M represent the amount of milk money. Well, how do we measure milk money typically? It could be coins, right? It could be dollars. So let's let M represent the amount of milk money. Of milk money collected in dollars. Okay. So again, we're just being a little bit more specific in our descriptions here to help us really move toward where we're going to be evaluating. So we were just writing, but look what we're doing now. We're writing and evaluating only addition and subtraction expressions. So we're not going to be multiplying or dividing today. We're going to read each story problem. We're going to identify the unknown quantity and write the addition and subtraction expression that is described. So much like we've been doing over the past few lessons, but here's the new piece. Finally, evaluate your expression using the information given in column 4. So 1, 2, 3, 4. So here's column 4. It's going to say evaluate the expression if. So if there's this amount. So this is kind of like column 4 is kind of like what we've been working on with substitution, where we substitute a value in for the variable. But in this case, it's going to remember before when we were substituting, we got to pick the variable. This time it's going to tell us the value of that variable. So that's where this is where the new thinking happens from 4 to 5 here, okay? All right, so let's see the example. It's always good to look at your examples and make sure you understand what to do before you move on. So we're going to start with the story problem. Greg has $2 more than his brother Jeff, okay? So we've got this is a number, 2 more is what's happening. So it's addition or subtraction. More means, right? Add, then his brother Jeff. Write an expression for the amount of money Greg has. So identify the unknown quantity. What do we not know? We do not know how much Jeff has. So look what it says here. Let J represents Jeff's money in dollars. The expression for this, how do we find how much Greg has, would be Jeff's money plus $2 more, which is here. And then here's where the new thinking comes in. Now they're going to say, oh, by the way, I know you didn't know what Jeff had before, but now I'm telling you Jeff has $12. So we take our expression, J plus 2, we substitute the value of Jeff's money, which is $12 in for J. 12 plus 2 would give 14. That means Greg ultimately has $14. So we have to play by whatever they tell us here, play by these rules. We have to put in this amount, okay? We're not going to make up our own amount. Okay, let's go to this story problem and get one more example. Greg has $2 more than his brother Jeff. Okay, so this is the same, right? Write an expression for the amount of money, though, that Jeff has. So there's the difference. Does everyone see that? This said Greg. This says Jeff. So what do we not know anymore? What are we trying to solve for? We're trying to solve for G for Greg, okay? Because we don't know how much money that Jeff has. So let G represent Greg's money in dollars. And we have to think backwards. If this is Greg's money and we take away $2, then that's going to tell us the amount of Jeff's money. So this is same words, but different type of thinking. So if Greg has $14 and our expression was G minus 2, if we put in $14 for Greg, 14 take away 2 equals 12. Jeff has $12. So this was kind of a continuation, but a different type of thinking. So let's see if we can put this into practice. So Abby read 8 more books than Kristen in the first marking period. Write an expression for the number of books Abby read. So write a description with units. So what are we going to be identifying, or what are we going to be finding? Okay, we want to write an expression for the number of books that Abby read. We know she read 8 more than Kristen. So let's let K represent the number of books Kristen read. It said in the first marking period. In the first marking period. All right. What expression would help us solve for Abby? Abby read 8 more than Kristen. So 8 more would be K plus 8. If Kristen read 9 books in the first marking period, how could we actually show our work and evaluate, which again means to solve? Well, we could say if the expression is K plus 8, we're substituting in for Kristen's value. We're substituting in a 9. So this is in fact going to be 9 plus 8, which ultimately equals 17. So we could say that Abby read 17 books in the first marking period. Okay, let's turn the page. We're going to practice a few more of these, okay? And you'll notice like this is a repeat, just like the previous 2 examples. Sometimes they repeat, sometimes they don't. And that's okay. Look what it says now. It says Abby read 6 more books than Kristen in the second marking period. So again, we have Abby, and she's reading more. But this time it says write an expression for the number of books Kristen read. So we need to solve for Kristen this time. So what, if I'm looking, what was my previous headings? Let me write those over here. So this was my description with units, okay? This was my expression. This was, they called that the evaluation of the expression. And this was show your work and evaluate. Sometimes it's good to copy those headings back down so you know exactly what you're supposed to do. Show your work and evaluate. So description with units. So I'm trying to describe what I don't know, okay? And I don't know the number of books that Abby read. So what do I not know that's going to help me solve for Kristen, right? So I don't know what Abby read. So let's let A represent the number of books Abby read in the second marking period. So let A represent the number of books, and I am going to run out of space here, so I'm going to have to just keep it like that. Let A represent the number of books Abby read in the second marking period. So what expression is going to show how much Kristen read? If A is the number of books that Abby read 6 more books than Kristen. So how am I going to solve for Kristen if I only know Abby? Well, to previously, remember, it would be Kristen plus 6 would equal Abby. Now I'm going to go in reverse. So Abby take away 6 would equal Kristen. So sometimes you got to think a little bit backwards. All right, now let's solve. So Abby read 20 books in the second marking period. So that's going to help me solve for Kristen. If Abby read 20, I'm still taking away 6. 20 take away 6 is 14. And that means that 14 books were read by Kristen. All right, Daryl has been teaching for 1 year longer than Julie. Okay, 1 year longer than Julie. Longer is another way of saying more than. Write an expression for the number of years that Daryl has been teaching. So we're trying to solve for Daryl. Okay, and if we're trying to solve for Daryl, we need to know. So Daryl, right, is going to equal 1 year longer than Julie. So Julie is the unknown variable here. We're going to let J represent, trying to keep my hand out of the way, represent Julie's years teaching. Notice I have to put my units in there. So she's doing years. So if Daryl's been 1 year longer than Julie, then that means it's Julie's amount of teaching plus 1 more year because it's 1 year longer. So let's see if we can actually solve for Daryl's year teaching. If Julie has been teaching for 28 years, that means instead of J, I'm going to put 28 plus 1. So Daryl's been teaching for 29 years. Okay, the best way to write this would be Daryl has been teaching for 29 years, but I'm just a little bit out of room for that. All right, let's do a couple more. Go ahead and pause the video. I want you to try to do these 3 on your own and then push play when you're ready. And let's see if you were able to come up with your descriptions, your expressions, and actually solving. Okay. All right, Ian scored 4 fewer goals than Julia in the first half of the season. Write an expression for the number of goals that Ian scored. So if I need to solve for Ian, then Julia is my unknown variable. So let's let J represent Julia's goals, right? Scored. So we're measuring in goals scored, the number. Okay, so if Ian scored 4 fewer than Julia, then that's going to be Julia's goals take away 4. That's a subtraction symbol. Now we can solve. This is our expression. We're going to substitute in Julia scored 13 goals. So our 13 takes the place of our J. We're taking away 4. And 13 take away 4.
Bus 1 has arrived. Bus 1
equals 9 goals scored by Anne. Okay, and look what it does on the next one. Now it says Anne scored 3 fewer goals than Julia. In the second half of the season, write an expression for the number of goals Julia scored. So now we're trying to solve for Julia. So we're going to be using Ian's number of goals that Ian scored to help us solve this expression. So let's let I represent the number. I have to use an abbreviation for number. The number, you guys know this represents a number, not hashtag, right? Okay, so the number of goals Ian scored in the second half of the season. So if we were solving for Julia, we would say Ian scored 3 goals. Or I'm sorry, if we were solving for Ian, I said that backwards, then it would be Julia, take away 3, right? But we're solving for Julia. So we have to do the opposite that we're doing here. So if Ian scored 3 fewer than Julia, that would mean Ian's goals plus 3 more would represent Julia's score. Another little hint here is they're telling you what Ian scored, so you know that you're going to have I as the variable here, or Ian's value as the variable. So if we have our expression, Ian's goals plus 3 more to get Julia's, then if they're telling us that Ian scored 3 goals, then that means Julia, 8 goals, sorry. That means Julia scored 11 goals.
Bus 2 has arrived. Bus number 2.
By Julia in the second part of the season. All right. Joanne visited Niagara Falls 3 times fewer than Arthur. So 3 times fewer than Arthur. Write an expression for the number of times Joanne visited Niagara Falls. So we're going to let's do A represent the number of visits by Arthur. Okay. And Joanne visited 3 times fewer than Arthur. So if this is Arthur's amount, then 3 times fewer would be taking away 3. So A, I know that kind of looks like a 9. I better clean that up a little bit. A, take away 3. So how do we solve for Joanne's visits? Well, Arthur visits Niagara Falls 5 times. We take away 3, then that means Joanne visited 2 times. So 2 visits by Joanne. All right, so I hope you did well with that. When you turn the page, you can see that your problem set is 4 more practice problems just like this. And this is going to be really beneficial to us because when we come back and we do lesson 19, we are going to be continuing on. So using evaluating addition, subtractions, expressions, but this time with substituting.
Buses 14 and 15 have arrived.
All right.
Buses 14 and 15.
Go ahead and do your best on this assignment, and I will see you in class.